Hey guys, welcome back everybody. So today we're going to talk about how to configure the E-BGP routing protocol on a GNS3, right? So we have some limitation on the Cisco packet tracer. That's why we are moving towards the GNS3. So today we're going to talk about how to configure the indirect E-BGP neighborship. In the last video, if you remember that, we covered the E-BGP direct neighborship, which is happening in the same broadcast domain. If you see this topology right now, in the last days, we have configured the neighborship between this two guy, 12.1 and 12.2, which is a part of the same broadcast domain. Now today we're going to cover the indirect neighborship between this network to this network. So there's a lots of use case of the indirect E-BGP neighborship, right? So one of the use case is what? So let's say example, you have a multi-hop session, right? Which is not directly connected. In that case, you can use the indirect neighborship. So for the indirect neighborship, what happened? You have some additional command. So let's start with the configuration of the IP address first. So I'll go to the router number 1 and interface 0/0 IP address will be 10.1.12.1/24 and no shutdown. I have a loopback as well. Loopback is a logical interface. It's not associated with any kind of hardware, and because of that reason, it doesn't have any MAC address as well. So IP address will be 101.1/8, and then I have a router number 2 as well. On router number 2, I'll configure this guy interface 0/0 12.2/24 no shutdown, and I have a loopback. Loopback will be 2.2.2.2 and /8. So if you have a look over here, so interface 0/0 include BIA. So I have a interface MAC address. That's a physical interface. But if I look for the same thing on the loopback as well, so loopback doesn't have a MAC address. And because of this reason, right, you cannot see the loopback in the ARP table as well. So now the IP part is done. What we can do that, we'll go with the BGP neighborship, indirect BGP neighborship. So first of all, what I can do, that better to write the configuration in the notepad, right, so that everything will be clear. So on the router number 1, I'll go to the config terminal, right, and as the router BGP number 1. So I'm assuming that this guy is belong to the AS number 1, which is the Airtel company, right, and we are forming the neighborship with the AS number 2, which belongs to the Geo, right? So on the router number 1, we have router BGP1. So the BGP router ID. This is the command to give the router ID for the BGP protocol. So if you don't define the router ID manually, it will go with the highest loopback interface. And if you don't have a loopback, then it will go with the highest physical interface. So that's done. And I'm going to say the neighbor, because router 1 is going to form the neighborship with the 2.2.2.2, right? And this 2.2.2 is belong to the AS number 2 right now. All good. After that, what happened by default, if you remember that, when I'm going to make a ping from the router number 1, let's example, I'm going to ping from router number 1 to the 2.2.2. In that case, what happened, the source is by default will be 12.1. This is the default behavior, and the destination will be 2.2.2.2. So if you see that, am I forming the neighborship between this guy to this guy? No, right? Because I'm forming the neighborship between this guy to this guy. But what happened, the default source will be the 12.1. So to modify the source, right, to modify the source, what we have to do that, we need to go under the neighbor and say that, hey, listen, the source is not a 0/0 interface. The source will be the loopback now, right? So we need to modify the source in the case of indirect E-BGP neighborship. That's all on the router number 1. On the router number 2, we have the same thing. Router BGP number 2, BGP router ID will be 2.2.2.2, and neighborship router 2 is going to form the neighborship with the loopback number 1 of the router number 1. They belong to the AS number 1, and then I need to modify the source as well. Update source loopback number 1, and that's all. So now we are good to go and put this configuration on the router side. All good. Same thing on the router number 2 as well. Perfectly fine. So if you see that the configuration is done, but still you will not see the magic log message, the neighborship is up. The reason is only that BGP is a TCP based protocol, right? And TCP always check the reliability. So what happened when the router 2 is forming the neighborship, the 1.1.1.1, it will check the reachability for the 1.1.1. Apart from the reachability, right, it also check the exact match route in the routing table as well. So do I have a route for this guy 101. If you see, I don't have it. Same thing on the router number one. When the router number one is trying to form the neighborship with the this guy, router one will check the reachability for this guy. Hey, do I know the 2.0.0 in my routing table right now? No, I don't have a 2.0 right now. So if you don't have a 2.0 right now on the router number one, and on the router number two, if you don't have a 1.0 route, then it won't form the neighborship. So BGP needs a reachability, right? BGP needs a reachability. So to provide the reachability, what I can do that I have multiple options. Either you can go with the any IGP protocol like a OSPF, EGRP to make a reachability, or either you can go with the simply static route as well. So why not go with the EIGRP OSPF? See, you can go with the EIGRP OSPF as well, but if you're gonna run the EIGRP and OSPF routing protocol, then extra processing will be required on the router side, right? At the same time, what happened? These protocols are periodic send the hello packet that's consume the bandwidth as well. So what if you have a small topology? It's better to go with the static route, but if you have a big topology, you better to go with the any IGP protocol. So I'll go with the router one as the IP route 2.0.0/8, and my next hop will be 12.2. Same thing on the router number two, IP route 1.0.0/8. The next hop will be 12.1. So after putting this command, what happened now? The device has a reachability and they will form the neighborship as well. This is done on the router number one, and this is done on the router number one as well. All good. Now I can see, let me check, do show IP route now. I have a 2.2. Let's make a ping. 2.2.2.2.2 source loopback number one. I do have reachability. So BGP summary, right? Still in the ideal. What's the reason is that? So run section BGP. So IP interface brief. That's good. Show IP interface brief. This is good. So run section BGP. Okay, this is good. Update source loopback number one. How about this guy now? So run section BGP. Okay. Oh, sorry, something is missing, right? So the one thing is missing that over here, we haven't configured the multi-hop. The reason is that, so normally what happened, E-BGP router, right? E-BGP protocol has a by default TTL is 1, right? And I-BGP has a by default TTL is 255. So when you're going to configure the E-BGP multi-hop session, right? So let's say example, when the router 1 is going to send the open packet of the BGP, it's going to send the open packet to the router number 2 with the TTL1, right? We have a source IP address will be 101, destination will be 2.2.2. So when the router number 2 will receive this packet, router 2 said that, hey, listen, this TTL has only one, so I'm going to accept this packet, right? I'm going to accept this packet. But after accepting this packet, what happened? The TTL will become the 0 now, right? In that case, what happened? Router 2 cannot forward this packet to the different broadcast domain. Every loopback interface is treated like a separate broadcast domain. Same thing on the router number 2 as well. When the router number 2 is going to send the packet, they have a source will be 2.2.2.2.2, destination will be 101, the TTL will be 1 by default for the E-BGP. Now what router 1 will do that? Router 1 will accept this packet, and once they will accept this packet, they will make the TTL will be 0. Now router 1 cannot forward this packet to the different broadcast domain. Because of that reason, what happened? The open packet is not able to extend between the routers. So what we can do that, we need to increase the TTL. How we can do that? We need to simply go on the BGP neighbor 2.2.2.2.2 as the E-BGP multi-hop. So here you can do the multi-hop 2 as well. And here I can do the neighbor 101 E-BGP multi-hop. I just want to show you one thing. If I'm not going to define the any particular value, then by default it will take the 255. Make sure that you need to define the certain values, whatever the requirement you have. Because if you're going to increase the TTL, multiple TTL, then anyone can perform the TTL attack in your network. So better to give the exact number of the TTL. Here I'm just doing the practical. That's why I'm not putting the any command line away, just to show you that if you don't put the any TTL away, by default you will take the 255. And that's good. Now let's go on the router number 1 and configure this guy again. Over here, good. All good. So now wait for some time, it will show the log message. Now you can see that my neighbor has come up, and you can see that the E-BGP multi-hop, I haven't defined any TTL value. So if you see the show run section BGP and have a look, the TTL is 255 now. So if you don't define any values, it will take the 255. Now you can also see the show BGP summary. I have a my local identifier is 2.2.2, my local AS number is 2.2.2, and neighborship is up right now. I haven't received any prefix from my neighbor. That's good because we haven't advertised yet. And you can also take the show BGP neighbor command. It will show you that my neighbor is 111, the remote AS is 1, and the link is external. So when the link is external means what? It's a E-BGP neighborship we have. So router 2 is clearly forming the neighborship with the router number 1. And router 1 is also clearly forming the neighborship with the router number 2 as well. So if you see on this guy as well, so BGP summary, you can also use the command so BGP IP summary as well, almost give the same output. And you can check the so BGP neighbor as well. The so BGP neighbor will give you the same command line, the neighbor 2.2.2, the remote AS number 2, and the link is external right now, and the remote router ID is a 2.2.2.2. That's how you can form the BGP neighborship. Few verification command you can write down over here. So you can use the verification, right? So BGP summary, right? You can also use the so IP BGP summary. Both have same meaning. You can also use the so BGP, so IP BGP neighbor as well, right? So let's say example, if you have a bunch of neighbor in your production network, right? So you can clearly mention that over here. So let's say example, I have 100 plus neighborship, right? And it happens in the production network. In that case, what you can do that you can simply mention that so BGP, sorry, so IP BGP neighbor, and mention the specific neighbor as well, 2.2.2.2. So it will give you the only a specific neighbor, not give you the all the neighbor. So I'll put this command as well over here. All good. So see you in the next video, guys. Thank you so much.